All right, 18.1 and 18.2 multiplying polynomials. Again, you can pause this video or skip ahead at any time if it seems too boring and you've got it, or you want to go back and relearn something or visit something again because you didn't understand it, or you think I went too fast, or you need to take time to write it down. So go ahead and pause the video and write these into your notes if you need to. All right, let's begin. When multiplying monomials, we're going to multiply the coefficients first, and then we're going to add the exponents. So here are our coefficients, 5 and 6. We're going to multiply those together. 5 times 6 is 30. And then we have x times x, so we have x, and x cubed times x squared. Remember, we add the exponents. X cubed times x squared is going to give us x to the 5th. Second example, a negative 3 times 7 is going to give us a negative 21. And then we have an x times an x. It's the same base, so we can put the base down. And remember, this is x to the first power if we don't have an exponent written there. And 1 plus 4 is 5. Once you go ahead and try this one, I'm going to go ahead and pause the video, work out this third one. Remember, only multiply the variables that only add the exponents together that match. So only add the exponents between the z's, the y's, and the x's. Go ahead and give it a try. Go ahead and pause the video. Okay, multiplying the coefficients, 2 times 4 is 8. Multiplying the x's together, add the exponents, 1 plus 5 is 6. Multiplying the y's together, y to the second times y to the first is y cubed, and z to the third power times z is z to the fourth. Now we're moving on to multiplying a monomial, or multiplying a polynomial. This is a polynomial by a monomial. Monomial meaning 1. Polynomial, again, separated by adding and subtracting signs. This is a polynomial, 3 terms, 1, 2, 3, and this is a monomial. Again, doing the same thing, but we're using the distributive property. We're going to multiply this times this, then that times that, and then this times this. Again, all we can combine are the x's, the same bases. Fortunately, these x's, these are all same bases, so we're going to go ahead and multiply. 3 times 6 is 18. X squared and x to the 4th is going to be x to the 6th. Then I multiply 3x squared times a positive 8x cubed. 3 times a positive 8 is going to give me a positive 24. X squared times x cubed is going to give me x to the 5th. And then 3 times a negative 7 is going to give me a negative 21. And x squared times x to the 1st is going to give me an x cubed. Okay, why don't you go ahead and give this one a try. Pay attention to the negative signs. Distribute this monomial to this polynomial. Go ahead and do that real quick. Pause the video and then resume when you have the answer to check it with mine. Okay, you should have got this result, 24x squared plus 4x cubed minus 4x. Remember that the exponent with just a base of x or just a base of y is going to be just 1. Okay, moving down to the bottom one. Got to be careful on this one because now I've got 2 different bases. I've got an x and a y. So I can only multiply the bases of my x's together and multiply the bases of my y's together. Again, using the distributive property. Same principle, we just have multiple variables within the same monomial. So again, 2 times 6 is going to be 12. X squared and x to the 1st is going to be x cubed. And y cubed times y to the 1st is going to be y to the 4th. There's our first one. Now we've got 2 times a positive 4 is going to give us a positive 8. X squared and x cubed is going to be x to the 5th power. Y cubed times y cubed is going to be y to the 6th power. Again, pause the video if you need to before moving on to make sure that you are doing everything correctly. Or go back and repeat if you need to hear the instruction again. Now we're going to multiply 2 polynomials together. First, we're going to use the distributive property like we did the first time. So I'm going to take this x and multiply it times that x. Then I'm going to take this x and multiply it to that 7. Then, next, I'm going to multiply this 2 to this x, and then distribute this 2 to that 7. There's several ways to do this. We're going to start with the distributive property first. So, I've got my x times my x. Again, that's 1 plus 1. That's going to be my x squared. Then I'm going to have x times a positive 7, which gives me positive 7x. Then, going to my 2, a positive 2 times x is going to be a positive 2x. And then I have my 2 times my positive 7 is going to give me a positive 14. At this point, I need to combine the like terms. I've got an x to the first power and an x to the first power here, so I can add these two coefficients together with my x's. Remember, you're not multiplying these, so the x still stays the same, and my answer is going to be x squared, and 7 plus 2 is going to give me 9x's, and then my 14's hanging out here as my only constant. Why don't you go ahead and try this one using the distributive property. Again, distribute the 2x to the 3x, then distribute the 2 to the negative 8. And then when you're done with that, distribute the 4. 4 times 3x, and then 4 times a negative 8. Use it the same process over here. If you need to rewind and watch my process, fine. If not, go ahead and tackle it. Pause the video and resume when you're ready for the answer. Okay, the answer is 6x squared minus 4x minus 32. Again, when you multiply these out by distributive property, you can combine these like terms. X to the first power can be added to x to the first power, but we cannot add x to the second power to x's of the first power. That's why we have to keep these separate. Now we're going to move on to the same. This is the distributive property, but in a very specific order. Okay, the F stands for the first term. Okay, the O stands for the outside terms. The I stands for the inside terms, and the L stands for the last terms. Now I'm going to do these in a different color. I'm going to do the first terms in red. I'm going to do the outside in green. I'm going to do the inside in blue. And I'm going to do the last in purple. Purple. Okay, I'm going to multiply the first terms together. X and the X are the first terms. So X times X is going to give me X squared. Next I go to my outsides. My outsides are going to be my X and my 10. Those are my outsides. So x times a negative 10 gives me a negative 10x. Then I'm going to go to my insides. My insides are going to be my 8 and my x. Positive 8 and a positive x is going to give me positive 8x. Then I go to my last terms, and my last terms are going to be my 10 and my 8. And 8 times a negative 10 gives me a negative 80. Again, this looks similar to the distributive method where I do x times x, then x times 10. It's actually the same as using the distributive method before, but some people like this FOIL method so they can remember how to do it. Again, if you use the distributive property x to x, then x to 10, you're going to get the same order down here. All right, now we need to combine our like terms, our negative 10 and our positive 8x, and we get x squared. And a negative 10 and a positive 8 leaves me with a negative 2 and then negative 80. Okay, why don't you attempt number 7. Again, do the first terms, 2x squared times 3x. Then the outside, 2x squared times positive 4. Then the inside, negative 1 times 3x. And then the last terms, negative 1 times a 4. Go ahead and pause the video, do that, and then resume the video when you're ready for the answer. Hopefully you paid attention to the squareds here. You ended up with 6x cubed plus 8x squared minus 3x minus 4. Now, unlike over here, you cannot combine these terms because I've got x to the first power here and x squared and x cubed. You cannot combine the bases if they have a different exponent. So we keep it as it is and not worry about combining any terms. Now I'm going to show you a third way to multiply polynomials using what I call blocks. Now I wouldn't normally do this using a binomial times a binomial. But it does get helpful when you start multiplying trinomials together, or a binomial times a trinomial, which we'll do next. But I want to show you this for simplistic reasons. So we're going to take our first binomial and put it up here. We've got a positive x and we've got a positive 8. This next one over here, this binomial, is a positive x, we're going to put it down here, and a negative 8. And now we're going to multiply these two together and put them in this box. So we've got x times x is going to give us x squared. Then we're going to multiply together x times 8, which gives us 8x. Now I'm going to write this in purple too, because it's going to be the same variable attached to this, but x times a negative 8 is going to give us a negative 8x. And then on our last term here, we've got a negative 8 times a positive 8, which gives us a negative 64. Now when our x's are of the same, so we don't have an x squared and an x to the first power here, for the x's are the same, our middle terms, these ones in here, are going to be the ones we're going to combine together. Okay? So we see that a negative 8x and a positive 8x cancel each other out. So our final answer for this is going to be x squared. Then a minus 8x plus 8x is going to give us a plus 0x. We're not going to write it. And then we're left over with that 64. This is what we're going to call a difference of squares. We'll get into that later when we start factoring. So keep a note of this one. It's a very easy way to factor. I'll show you that when we get to factoring next week. All right. For this one over here, again, we're going to write the first one in green. We've got 2x, and then we've got a negative 1 over here. And then our second one, we've got a 2x plus 1, and a 2x over here, and a plus 1 over here. I don't write the plus 1. You can if you want to. All right, 2x times 2x, excuse me, is 4x squared. 2 times a negative 1 is going to be a negative 2x. 2x times a positive 1 is going to give us a positive 2x. Again, these are going to cancel each other out. And a 1 times a negative 1 is going to be a negative 1. So I can circle these because I'm going to combine these and end up with 4x squared minus 1, because the middle terms, 2x, and I add them together, and a negative 2x are going to cancel each other out. Okay, here's where the block method becomes particularly useful. Now, you could go ahead and use the distributive property here and take and multiply x times x squared, then x times a positive 2x, then x times a negative 9, and then the second time you distribute a positive 1 times x, then a positive 1 times a positive 2x, and a positive 1 times a negative 9x. And you can absolutely do that. You're going to have a big long string of numbers. In fact, you're going to have 6 of them all in a row, and you're going to have to figure out which ones to combine, like we did in our lesson prior to this, 17.2 and 17.3, underlining, boxing, whatever. This, I find, is a lot easier to organize. So I'm going to write my first terms here, my x, my positive x, and I have a positive 1 here. Then I'm going to write my second, this is a trinomial here. This one's going to go x squared, and I've got a positive 2x, and I've got a negative 9. This is just easier organizationally. You can do it the distributive way or do it the block way. All right? So then I've got my x squared times my x gives me an x cubed. X squared times a 1 gives me a 1x squared. X times a positive 2x gives me 2x squared. Then a positive 2x and a positive 1 gives me a positive 2x. Then x times a negative 9 gives me negative 9x. And a negative 9 and a positive 1 gives me a negative 9. Now if I look here, I notice that I can combine my x squareds. Instead of having to box them in and circle them in that big long string of 6 numbers, I got my x squareds here. And then if you notice, I've also got my x to the first powers here. And I just combine those. So when I combine everything together, I combine my x cubes. I have no other x cubes. So we have got x cubed here. Then I combine these. 2x squared and a 1x squared gives me a 3x squared. And then I have a negative 9x and a positive 2x, which gives me a negative 7x. And then I've got a negative 9 sticking out here all by itself. And there I have it. It's done. Ha! I moved everything while you weren't looking. I moved this down here so we can have some room to write. Right, again, I'm going to write this first binomial because it's got two terms. It's separated by one addition sign, so I've got two monomials here. It's a binomial. So I put my 2x here and my 3. Sorry, we skipped that lesson. I just figured I could explain it to you as we go. This is a trinomial because it's separated by negative and positive signs. So this is one monomial, another monomial, another monomial. So I'm going to write the second one, which is a trinomial here in blue. X squared minus 4x, and then I have a negative 12. At this point, I'd like you to go ahead and pause the video and multiply these together like we did in the one to the left, and then combine the like terms by circling the ones you can add together. And go ahead and resume the video when you have your answer. So you could have, or should have, combined these x squared terms together. Negative 8 and 3 is a negative 5. And negative 24 and negative 12 is negative 36. Again, only bases with the same exponent can be combined. Now just to show you, just a little different here, I'm going to scroll down here, and I did these same exact problems except using the distributive method. And again, when I combine my like terms, I either box them, underline them, or circle them, or however you get to organize them. And notice I come up with the same exact answer. I'm not doing anything different. The multiplication's the same, but if you notice, that answer is the same as this answer. I use the distributive method here, and moving up, I use the box method up here. Okay, going on to this one. Again, use the distributive method instead of using the box method, combining the like terms. And again, I got the same exact answer here as I got here. So depending on which way you want to do it. This is the distributive method here, and moving up is the box method. And you can choose either way to do the multiplying of polynomials. All right, we've got 2 more slides and then we're done. This is the second to the last one. Now I'm going to multiply a trinomial times a trinomial. Again, you can do this and you're going to have 9 terms down at the bottom if you wanted to use the distributive method. I am not going to do that one this time. You can knock yourself out and do that by multiplying, again, distributing your x squared first, then distributing your 7x, then distributing your 12. I'm going to use the box method here. And it's just an easier way to organize, in my opinion. All right? So I've got my x squared, my first trinomial. Again, this is 3 monomials stuck together, separated by a plus or a minus sign. Not talking a negative sign, but adding or subtracting together. This has 3 terms in it. This has 3 terms in it. Therefore, it's a trinomial times a trinomial. Got a positive 7x, a positive 12. This one down here, I've got an x squared, I've got a positive x, and I've got a negative 5. Okay, my x squared times my x squared is going to give me x to the 4th power. X squared times 7x is going to be 7x cubed, and 12 times x squared is going to be 12x squared. X squared times x is going to give me an x cubed. X times 7x is going to give me 7x squared, and x times my 12 is going to give me 12x. X squared times a negative 5, negative 5x squared. 7 times a negative 5, negative 35x. Negative 5 times negative 12 is a negative 60. And then looking at my combination of terms, I can combine my cubes. I can combine my squareds. I've got 3 of them this time. And then I can combine my x to the 1st powers. Okay, I'm going to move the screen up just a tad so I can got some room to write, and then write this out. Oops, darn it. All right. Now we've got my x to the 4th. This is all by itself here, x to the 4th. Then I've got my x cubes. 7 plus 1 is going to give me 8x cubes. So now I've got 8x cubes. Then I have 7 and 12 and 5. If I notice here, too bad my 7 and my 5 can't combine, and it's negative, and those cancel each other out. but I've got a positive 7 and a negative 5, which leaves me with a positive 2. 2 plus 12 is going to give me a 14x squared. Then I've got my 35 and my 12. So same sign, add and keep, different sign, subtract. 35 minus 12 is going to give me 23x. And then I've got my negative 60. Let me pause here and double check my math. Let's move on to the second one now. My first trinomial. Again, this has 3 monomials in it. Constant here. It's trinomial by times a trinomial. So I'm going to write my first here, 2x squared. And I have my positive 5x. And again, I'm not writing my positive signs here. I'm just going to do it if it's negative, and my 10. The next one over here is going to be my 3x squared. Then I've got a negative 4x and a negative 2. At this time, I'd like you to pause the video, go ahead and multiply all these together, combine your like terms, and write the answer along the bottom. Go ahead and hit resume when you're ready to check your work. Again, I can combine my x cubes, which gives me 7x cubed, combine my x squared, which gives me a positive 6x squared, excuse me, and then I combine my x to the first power, and those are going to be negative 50x. We've got one more slide. It's kind of a real-world problem. This figure represents a picture frame. We don't know the dimensions yet. We're just going to find the area of the frame. Now, we don't know what x is going to be equal to, so we're going to be thinking in polynomials. What I'm going to have to do is I'm going to have to take the large area, which is this times this, and I'm going to have to subtract the small area to find the shaded area in blue. So what I'd like you to do, you know which ones we have to multiply together, and then we have to subtract. This is putting together the lesson from last time and this one, so we're going to have to subtract one. So multiply these two together. Again, I'm going to write it over here as 3x minus 1 times 2x plus 3, and then we're going to have to subtract the product of x plus 2 times x minus 3. I'd like you to go ahead and multiply these together, and then subtract the green from the black one, and see if you come up with the same answer. Again, combining this. So go ahead and pause at this time and work that out, and then compare it to my answer. And hopefully I got all the correct answers as well. Again, if you find a mistake in any of my videos, I try to double check. Please email me and I will give you extra credit. All right? I appreciate it. Go ahead and pause right now and work it out. So I'm pausing or opening it up here just to show you my first product is going to be my 6x squared here minus 7x minus 3. My second product is going to be x squared minus x minus 6. Now I need to take this and subtract this. I'm going to move the screen up just a tad so I've got some room to work. Notice I did the first one in the box method and the second one just using the distributive or the FOIL method. So now I'm going to subtract these two. Go ahead and hit pause again unless you've already done it and see if you've got the same answer as I do. Okay, this is the first section here. I just wanted to remind you, make sure you distribute this negative 1 to all these. Remember, it's this polynomial minus that one, minus the entire quantity. So make sure you set it up properly first before you do the math. Okay, I did my polynomial arithmetic in color, underlining my x squareds in black and my x to the firsts in green and my constants in purple, combining my like terms, and my final answer, the area of the shaded section, the blue section here, is 5x squared minus 6 plus 3. Again, you can go back through this video anytime and review it. There's going to be a quiz following this tomorrow. Today's date's the 15th. Tomorrow's the 16th for you to just check and see what you've learned. I'm going to include the answer. Again, it's just a review for you. Thanks for paying attention and watching, and let me know your feedback if you find especially any mistakes. Thanks, and have a great day.